So far this week, we've been discussing angle measure within the unit circle in terms of radians and degrees. And so now we want to talk about the measure of the arc length of the circle in terms of radians. So, there we go. Today we're going to be focused on finding arc length. And when we find arc length, so for any circle of radius r and a central angle of measure theta, but we want to make sure that theta is in radians, we're going to find the length of S, or the length of the arc length of the intercepted arc, is equal to the radius times theta. So when I'm talking about S, I'm calling the intercepted arc length S. So for example, here's the center of my circle. Here's the radius. Here's another radius. So we've created this angle theta, and we want that angle in radians. Then the measure of this arc length right here, and we're referring to that length as S, is equal to theta times the radius. So you're just going to say that S is equal to the radius times theta. So that means that the arc length is equal to the radius times theta, and theta needs to be in radians. So let's go ahead and do some examples and apply that formula to some specific examples. So in example 1, we're going to find the length of S to the nearest tenth. So you do need a calculator for these problems. You are going to actually find the decimal version of the answer. We're not going to leave them as fractions in this case because we're talking about distance. So when we talk about distance, we don't tell someone that something is pi centimeters long. Okay? Right? We tell them what it would be in decimal form. So find the length of S to the nearest tenth. We need to go ahead and draw it. So here's the center of the circle. And we are going to have an angle that measures, theta in this case is 5 pi over 6. The radius is 3 inches. So I know that this radius is 3 inches, which means this line is also 3 inches. And we're going to find this arc length. This is S. So remember, S is equal to the radius times theta, which is in radians. Well, our angle is in fact in radians because it's 5 pi over 6. Doesn't have a unit of degrees. So S is then equal to the radius, which is 3 inches, times 5 pi over 6. So S is equal to, so I'm going to take 3 times 5 over 6. Well, can't I reduce 3 over 6 before I multiply? So 3 goes into 3 once, 3 goes into 6 twice. So I have 1 times 5 times pi, so 5 pi, over 2. And then we have inches. So how did I know that I could multiply like this? Well, isn't 3 inches technically over 1? So then you have 1 times 2, which is 2 in our denominator. But we need this to the nearest tenth, so we need to go ahead and multiply this out. So in your calculator, you can just simply put 5 times pi divided by, and then I would hit enter, and then divided by 2, and I get 7.85. But we want to round to the nearest tenth, so 7.85 would then be rounded to S equals 7.9 inches as our final answer. And that's it. That's all you have to do to find the arc length. Super sweet, short, to the point. Why don't you go ahead and press pause? Oh, just kidding. You need the measurements of example 2 before you can get started on it. Sorry. So here's the center of our circle. And let's do an angle, a central angle that looks like this. We'll say that this angle is 2 pi over 3 radians. And then I want you to find the intercepted arc length right here. We'll call it S. So find what S is. S is equal to, remember, the radius of the circle times theta. And you probably need the radius of the circle. Let's say that the radius is still 3 inches, the same as the other circle. Yeah, 3 inches. All right, go ahead and press pause. Find this arc length without me, and then check your answer when you're ready to go. So what you should have is S equals the radius of 3 inches times 2 pi over 3. 3 inches is technically over 1. 3 divided by 3 cancels. We're left with 2 pi inches. But again, we want the decimal form. So 2 pi in our calculator would be 6.28. So rounding 6.28, we would say 6.3 inches. And there we go. That's all for today.